Assalamu alaikum and a very good morning to all. Welcome back to my channel, IQ Learning channel, and I hope you have enjoyed all my last videos about gaming and different types of books. So today we're gonna talk about our new book, which is Complete Chemistry for Cambridge Secondary 1. So this is a book for grade 7 and 8, but we're usually doing it for grade 7. The chapter which I'm going to tell is mostly for grade 7. It is done this book, so I'm presenting it. Okay, so the chapter we will be starting with 1. So the particle of theory of matter. So what are particles and the theory of matter? So our objective is to learn and use particles to explain the behavior of substances in the solid, liquid, and gas state. So we'll be defining and telling about different types of particles in their different states. For example, solid, liquid, and gas state. Okay, so let's start with this particle theory. So first we need to think like what is theory? What is a particle theory? What are particles and what is a theory? So particle theory is an incredibly widely believed theory of matter which holds essentially that matter is made up of small particles which are constantly moving. So if I summarize these 3 lines, I will be telling you that it means matter small. The particles of matter are small, and matter comes in 3 different types of states. Now let's learn about the next one. Next point, the particle theory is used to explain the properties of solid, liquid, and gas. The strength of bonds, the strength of bonds is also known as attractive forces. So we can also take it as the attractive forces between particles is different in all 3 states. So the forces between solid, liquid, and gas are different. How are they different? Why are they different? These questions might pop up in your head, so I'll be explaining them later. Now, the next point is particle theory is also known as high energy. So particle theory also has a nickname just like we do. Like many people have nicknames. So particle theory also has a nickname. Particle theory is known as high energy because of many fundamental properties. Particles. Most of the fundamental particles don't generally occur in nature, but can be generated by creating extremely high energy interactions between particles. So, and the third point isn't that like explanatory because it's actually not for this grade level, but I have been explaining it just for extra information. Okay, now let's learn about the properties and the particles in a solid. Okay. So, solid. What are the particles in solid and how are they attracted? They have low kinetic energy. I'll be explaining the kinetic energy in the next after the next 2 slides. And then in the particles of the solid are very strongly attracted to each other. They are closely packed in a fixed arrangement, very tightly packed, and they cannot move or vibrate. Move by vibrating. They move. They have little bit space, very, very, very little bit, but are very, very tightly packed together, and their kinetic energy is very low. They're strongly attracted to each other as just like magnets. You know, magnets attract each other very quickly and very strongly, just like an iron grip, okay? Now let's learn about the particle theory in liquid. Now, in liquid, they have medium kinetic energy and move by sliding past one another. So they have less kinetic energy, not that much, not more, medium. Okay, so medium equals to more and less. So they have medium kinetic energy and they move by sliding past one another. So they move a bit and they touch each other. Okay. Now, they has taken up the shape of a container. So they take the shape of a container, not like solid, because solid is the container. Gas cannot take out the shape of a container, can it? Nope, it can't, until we squeeze it. I'll be explaining this part again. So they have a medium. They take the shape of a container as you pour the liquid in a bottle, like. We didn't water in a glass. So we poured the water in the glass. Otherwise, it would be splattered all around, right? It's common sense. they are strongly attracted to each other. So they're not that attracted like in what we call the solid, but medium type, but are strongly attracted, not attached. They are attracted. And also they are closely packed in a free arrangement. So they're free but are touching each other in an arrangement, okay? But they don't have a pattern. Solid particles have a pattern. They're in a pattern, but liquid doesn't has a pattern. Now the particles in gas. Okay. So gas particles spread out to fill a container evenly, unlike solid and liquid. So the gas particles are further away from the particles. From the different particles, they're far away. They're not joined together like solid and liquid. They do not touch each other. They are freely open. Okay? Now let's learn about the next one. Gas is a state of matter that has no fixed shape and no fixed volume. So it's a matter. As we know, there are three states of matter. So gas, liquid, and solid. So gas it's also matter, but it has no fixed shape. It's the only matter which has no fixed shape because it's spread evenly. The particles are not joined together. Then gas has lower density than other states of matter such as solids and liquids. So gas has a lower density than the other states of matter because the density is like low in it because the particles are further apart and they're not touching each other. And in solid and liquid, not as much as in solid and liquid, but a little bit density has lower, okay? So then comes, there is a great deal of empty space between particles which have a lot of kinetic energy. So in solid, there is no kinetic energy, there is very less kinetic energy, and in liquid, there is medium kinetic energy, and in gas, much kinetic energy, lots of kinetic energy, because it's spreaded. The particles in gas are actually spreaded. Okay, now over here, I'll be showing you these three. So first of all, we have solid. In this, you can see that the particles are squeezed together. They're squeezed together in solid, okay? So they're squeezed together in liquid. They're further apart and touching each other. You can see these spaces, right? Yeah? Yes, you can see these spaces. I'll be showing the laser as well. These spaces over here, these are the spaces in liquid. This is the thing which these are the particles arrangement in liquid. So solid has a pattern. You can see the pattern, right? Like this, then this, then this, then this, and it's a pattern. It's type of like squares. But in liquid, there's no pattern because they're scattered around and something. And in gas, there's absolutely no pattern because you can see that in gas, they are all roaming around everywhere. You can see. They're not even touching each other because the particles are very, very far apart in gas. So let's learn about the next slide. Okay, so compressing solid, liquid, and gases. Let's learn what is compressing solid, liquid, and gases and how we can do it. So the compression of solid is difficult. Liquids are nearly incompressible, but gases can be easily compressed. So in summarizing these three lines, I can tell you that solids and liquids cannot be compressed together. They're incompressible. Solids are difficult to be compressed. Like, you can't squeeze a glass in your hand, can you? Nope, you can't. Liquid as well. You can't squeeze water. Can you? Nope, you can't. What about gases? What about when your mothers cook food from the gas which comes from the cylinders? There are gases compressed in it. Many different types of gases, like in the balloons, we compress the gas. The gas is closed, tightly packed inside. If we compress it inside, then the gas is tightly packed inside the balloon. So even in helium, in the tanks, the helium tanks are also compressed with the gas, with the nitrogen gas. Okay. Now, molecular arrangement of solid is regular and close, but liquids have irregular spare molecules arrangement, and gases do have random and more spare arrangements of molecules. So the molecules arrangement in solids are regular and they're close. Like, they're not that close as well, but they're regular, like medium, just like I told you in liquid. And in liquids, they are irregular, and there's pair molecules. So in liquid, they're like irregular, not at all. Okay, irregular also means not at all. And in gases too, they have random and are more spare arrangement of molecules. So in solid and in gas, the molecules are random, but in liquid, they're irregular. Okay, the molecular arrangement is in solid is well organized. So in solid, it is well organized, like it's like in one path, just like a pattern. Okay, so these 2 points mean that solid and solid only has a straight pattern. Liquid and gas does not. Okay. Now, why do substances expand on heating? This is a question many people don't understand, so I'm going to help you with this query. Now, when substances expand on heating, the state of the substance may change from solid to liquid or liquid to gas. So, actually, what happens when the substance is expanding on heating? The substance may change. It changes from one substance to the other one, from other substance to the one. Okay, so it happens like this. Since liquid occupies more volume compared to solid, and gases occupy more volume as compared to liquids. So over here, I can tell you that liquids occupy more volume compared to solids. Okay, liquids have more volume than solids. Gases have more volume than liquids. So first is gas, then comes liquid, and then pour solid, right? Then heating a substance increases its volume. So if we heat a substance, like if we heat water, what happens? Its volume starts to increase, right? Okay, this is the reason we say substances expand on heating. That's why we say it when we heat a substance, the molecules and the volume increases. So that's why we say it expands on heating. Substances expand on heating. Now, why do substances contract on cooling? Wow, the scientist is really mad over here. Okay, so over here, it says substances contract on cooling as molecules slow down. They take up less volume. So they take less volume, unlike the other one. When they're contacting and when they're compressing on heating, they take more volume. But in this one, they take less. So slow and less, and both equals 1. So over here now we will be telling us taking up less room because of molecules lower energy cause the liquid to contact. So taking the less room because the molecules lower energy cause the liquid to contract. Over here what actually happens is in lower energy, the liquid contracts less because the room is full of molecules of different types of energies, from lower to greater to medium and different. Then an expansion to this is water. So we can give an example as water. Water, if you pour it on the floor, it flutters around, right? Its molecules and energy is less because it's a liquid. Then we can say as water cools, it contracts until it reaches the freezing point. So when the water reaches its freezing point, it turns to solid, right? Like water turns to solid by freezing, and then we want to melt it, we do it ice to liquid. So solid to liquid, liquid to solid. So over here, it's type of like a process or something. Now, what we have learned, okay. So these are some very important points. You can note them down if you like, but it's better if you learn them with me. The particle theory explains how the substances behave in solid, liquid, and gas. So for the first slide, we give this explanation. This is the summarizing of the first slide I showed you, where it said about the particle theory. What is the particle theory? Then about solid, liquid, gas, and about compressing the substances. Then when you can compress a substance when it is in its gas state, but not when it's in its liquid or solid state. So as I told you over there, it's a very important point. It can come anywhere. Anyone can ask you about this. Which solid or which substance cannot be compressed and which can be compressed? So you can answer like that. You cannot compress a substance when it is in its gas state. You can compress only when it's in its gas state, not in its solid or liquid, because solid and liquid can be compressed, can it? No. So substances expand on heating and contact on cooling. So in the last two slides I just showed you right now, before this, the contact on cooling and expand on heating, it tells substances will expand when they're heated and they will contact when they're cooled. Okay. Now, everyone, I really hope you enjoyed learning to my lecture, and thank you for listening to me. I hope you paid attention, and I hope you enjoyed as much as I also did. So, hope you all enjoyed watching my presentation, and I hope you learned well. And don't forget to subscribe and click the little bell button to get notifications. Bye, and have a nice day. Just don't forget to subscribe.